Hi everyone! In this video, we're going to discuss Euler Tours. This is a continuation of our discussion of fundamentals of graph theory. To start, let's define what Eulerian means. A connected graph G is Eulerian or Eulerian if there exists a closed trail that includes every edge of G. Such a trail is called an Eulerian trail. We call it an Eulerian circuit when we do not need to specify the first vertex, but keep the list in a cyclic order. This is named after Euler in honor of his solution of the Königsberg problem. Kung natatandaan niyo yung introduction natin, i-discuss natin doon yung Königsberg problem. And explain natin kung bakit walang path na nag-exist that can traverse all the bridges in Königsberg. And that solution is given by Euler. Now, the definition of Eulerian graph requires that we traverse each edge of a graph one and only once, and to finish it at our starting point. So if you can traverse the whole graph once and only once for each edge. So you can repeat any of the vertices but not the edges. And then you can return to your starting point. Then that's a Eulerian Trail. And since we were able to find a Eulerian Trail, then that graph is a Eulerian graph. A non-Eulerian graph, G, is semi-Eulerian if there exists a non-closed trail that includes every edge of G. So, pwede rin na matatraverse mo lahat ng edge ng G once and only once. Pero hindi ka na makakabalik doon sa initial position mo. So, yung trail mo, hindi close. Ang tawag doon sa graph, semi-Eulerian graph. So, pag hindi close yung Eulerian trail, pero na-traverse mo pa rin lahat ng edges ng G once and only once, the graph is called semi-Eulerian. So these are examples of a Eulerian graph, a semi-Eulerian graph, and a non-Eulerian graph. So to make sure that this is indeed a Eulerian graph, we must be able to find a Eulerian trail or a Eulerian circuit. Again, the difference between a trail and a circuit is just the starting point. So for a trail, we must have a starting point and a terminal point. Now, a circuit is that same trail, pero we no longer need to distinguish kung saan tayo mag-start. So, kaya nga siya tinawag na circuit. Kahit saan ka magsimula, basta paikot, you just maintain the same circular manner on how you trace your Eulerian trail. Okay, so let's start with this edge. So, you want to make a Eulerian trail. So, you need to traverse all the edges. You can repeat traversing a vertex but not an edge until you reach the same initial point again. So let's follow this edge here. So from this point, I can choose any of the three edges. So let me take this edge, yung pataas. So akit ako. So I cannot go back right away kasi kailangan kong maikot yung buong graph. So pwede akong pumili from these two, right? So let me choose yung nasa taas. You can choose any path that you want. Just make sure na matitrace mo lahat at makakabalik ka sa initial. So punta ako dito, taas. Now from here, I can choose any of the three. So let's say I choose yung papunta sa gitna. So I have three options, but I cannot take this option yet. Hindi pa pwede. Bakit? Kasi pag pumunta na ako doon, kailangan ko nang bumalik doon sa simula. Hindi ko na napuntahan yung ibang case. Right? So, wag muna doon. Mamaya na doon. Pupunta muna ako either any of these two. So, let me go straight down here. So, in this case, wala na akong choice kundi pumunta dito sa baba. Kasi nadaanan ko na yung dalawa kanina. Okay? So, here, I cannot go on this yet. Kasi pabalik na yon. Kailangan malibot ko muna yung natitira pa. So, not yet here. So, let's say, dito ako sa labas. Okay. Yan. So, no choice na ako. So, I'm already on my way back to the initial position. Right? Okay. So, that's my Eulerian Trail. So, since I was able to make a Eulerian Trail, I traversed all the edges one and exactly once, and I was able to return to the original or to the initial vertex. So that means that this is a Eulerian graph. Now, as for a semi-Eulerian graph, let's say I start in this vertex here. So I can go out to any of the edges. So let's say I go out here at the center. Now from here, I can go from left or I can continue moving on or right. So let's say I go here. So I turn right. Okay. So from here, I can go right or left. So let's say I don't want to go back first to my initial point. So punta tayo dito. Yan. Okay. From here, you can choose any of the three. So let's choose going up. Okay, from here, I can go back in. Right? So I have no choice but to follow now this trail. Kasi wala nang natitirang mga edges. Now, I haven't yet traversed the last edge. But I will now miss my initial point. So, kung itatraverse natin tong last edge na to, hindi na tayo makakabalik sa initial point kasi na-traverse na natin lahat. But we were able to traverse all the edges. Yun nga lang, yung starting point mo tsaka yung finish point mo are not the same. So, it's not a closed trail. So, it's not a Eulerian Trail. But still, nadaanan natin yung lahat ng edges once and only once. So, this is a semi-Eulerian Trail. Or rather, this is a semi-Eulerian graph. Okay. Now, the third example is non-Eulerian. Let's see. If I start, so let's start at this point. Now, I can go to any of the edges here. So let's go down here. Let's go down. And then let's choose to the diagonal. Let's go to the diagonal. And then let's go down. So if I choose the bottom edge, I can no longer trace the upper edge and the diagonal. So if I choose, on the other hand, the diagonal, I can still trace the upper edge, but I'm done here. I cannot trace the last edge. So I won't be able to make a complete tour of the graph. So this is non-Eulerian. So again, a Eulerian graph is one in which you can tour all the edges once and only once and return to your initial vertex. Okay. Now, let every vertex of a graph G to have a degree of at least 2. then G contains a cycle. So what it tells us is that if the degree of each vertex is at least 2, then we can always make a cycle from G. This is really easy to show. Let P be a maximal path in G. So meaning it's a path of longest possible length, and let U be an endpoint of P. So suppose this is our path of maximum length from U up to this endpoint. Now, since P is maximal, then every neighbor of U must already be a vertex of P. Why is that? Because if there is another vertex that is neighbor to you, let's say this is another vertex not in the path, but a neighbor of U. Okay, so let's say that U and U prime are neighbors, but U prime is not in our path. Then our path plus this new edge U and U prime must be longer than P. Right? Pero sabi natin P na yung maximum length eh. So hindi pwedeng may mas mahaba pa sa P. So that means wala nang neighbor si U na wala pa kay P. So lahat ng neighbor ni U dapat na kay P na. Kasi pag meron pang isang vertex na wala kay P pero neighbor ni U, edi ibig sabihin hindi pala yung P yung pinakamahaba, may mas mahaba pa pala. Okay. So pag P is maximal, then every neighbor of U must lie in P. Okay? So, in this path, pwedeng dalawa, pwedeng tatlo, pwedeng lahat neighbor ni U. Pero sigurado tayo na at least may dalawang neighbor si U. Yung isang neighbor ni U, yung pinakakatabi niya sa path. Tama? The rest, malayo na kay U. Now again, since by assumption, ang degree ay at least 2, dapat may isa pa. Beside this neighbor, may isa pa dapat. Okay? So let's say may isa pa siyang neighbor, let's call that V. Okay. Pero since neighbor siya ni U at hindi siya yung pinakamalapit kay U, that means may edge connecting U and V na wala dun sa path. Okay? It doesn't make the path any longer pag dinagdag mo yung path UV kasi yung V na yon nasa path na mismo. Right? Okay. So, basta ang mahalaga lang, mayroong edge UV at yung edge na yon check tayo na wala dun sa path. Yung isang neighbor niya kasi na ang edge nasa path, yung pinakamalapit kay U. This one. So, since dahil dapat may isa pa, kasi nga at least 2, edi, since U and V are neighbor, then there must be an edge connecting them. And that edge cannot be in the path. Yan. So, anong nakita natin? We're able to see that yung path natin, right, plus yung UV, yung edge UV, forms a cycle. So, this one forms a cycle. So, every time na meron tayong at least degree 2, lahat ng vertex natin at least degree 2, then we can always form a cycle. Yan. Now, we can use this to prove that a connected graph G is Eulerian if and only if the degree of each vertex of G is even. So, this is another strong theorem in determining whether a graph is Eulerian or not. All we need to do is to find the degree of each vertex. And if the degree of each vertex is even, then the graph is Eulerian. An even graph is a graph with vertex degrees all even. So, even graph are Eulerian graph. So, how do we prove this? Again, this is biconditional. So, we need to prove two implications. One, we assume that a connected graph G is Eulerian. Then, we show that the degree of each vertex is even. Next, we assume that the degree of each vertex is even. then we show that the graph G is Eulerian. Okay. So, let's do the first implication. Suppose that G is Eulerian and let P be a Eulerian trail. Of course, since we assume that G is Eulerian, then there must exist a Eulerian trail or a Eulerian circuit of G. We need to show now that each vertex of G have even degrees. Right? So, kailangan natin pakita na ang degree ng mga vertex even. Now, imagine our Eulerian trail. For each vertex, may kang vertex. Para pag dumaan yung Eulerian trail sa vertex na yon, laging dalawa ng dalawa yung magiging edge incident to that vertex. Right? Yung isa, yung papasok sa vertex, tapos yung isa, yung palabas sa vertex. So, every time na dumadaan ka sa isang vertex, gamit yung Eulerian trail mo, laging dalawa yung edge na incident sa vertex na yon. Yung isa yung papasok ka sa vertex, yung isa yung palabas ka sa vertex. That's the same kahit na yung vertex na yun ay yung starting point mo, which is the same as your end point. Yep. Start and finish. So, yung una, yung nag-start ka, palabas ka dun sa vertex, and then later on, pagbalik mo, once you finish your trip, meron ka na namang edge papasok dun sa vertex. So, laging dalawa ng dalawa. So, whenever P, our Eulerian trail, pass through a vertex, it uses two incident edges. Tama? At ibig sabihin, every vertex has even degrees. Pwede mong daanan ulit yan at some other point in your trail. Pero, pag dinaanan mo ulit yan, bubuo ka na naman ng dalawang edge coming in and coming out from that vertex. So, always even yung number of edges na dumadaan or incident to our vertices. Okay. Now, on the other hand, if we suppose that the degree of each vertex in a connected graph G is even, what we want to show is that there's a Eulerian trail for us to say that the graph is Eulerian. So, how do we do that? So, we prove by induction on the number of edges of G that G is Eulerian. Okay, let's form our basis. If the number of edges is 0, so that means yung graph natin, para magkaroon ng zero number of edges, ay isa lang dapat yung vertex. Right? So, the Eulerian trail itself is doon lang sa vertex na yan. So, it consists of only one vertex. Now, if the number of edge is 1, right? So, meaning, isa lang number of edge, para maging Eulerian trail yon dapat closed loop siya. Self loop. So, a self loop consists of a vertex and an edge. Pero the condition na dalawa yung incident dun sa vertex, totoo pa rin. Right? Bakit? Kasi imagine if this is a self loop, that's one edge coming out. Right? Tapos, pagbalik mong ganyan, may isa na namang edge coming in. Though, this is just one edge, pero yung point of incidence ng loop, dalawa. Yung isang palabas, tsaka yung isang papasok. So, dalawa pa din. Okay. Parallel edges. Now, if M is equal to 2, then you have parallel edges, right? One coming in to from the first vertex to another vertex, and then babalik ka using the other edge. Yan. M equals 3. If you have a triangle, so ang Eulerian trail mo is you just trace the triangle. So meaning, whether M equals 1, 2, or 3, for as long as the number of edges incident to a point is even, 2, 2, 2, then there's always a Eulerian trail. So we have our basis. So let's assume that is the case. So assume natin na pag meron tayong connected graph G, such that ang number of edges niya ay m. Tapos ang degrees ng bawat vertices ay even. Okay. And then any graph with fewer edges satisfying that same condition contain a Eulerian trail. So, napakita natin na totoo yun pag m equals 1, m equals 2, m equals 3, and so on. So, let's assume that it is true for 1, 2, 3, up to m minus 1. Meaning, lahat ng graph, basta less than m ang number of edges, satisfying the condition na even yung number of edges incident to each of its vertices, meaning ang degree nung graph na yon ay even. Then we will show na our graph with m number of edges must also be Eulerian. Now, with even vertices, each vertex in G has degree at least 2, right? So by lemma, G contains a cycle. Kasi sabi ng lemma natin, every time na ang degree ng edges mo ay at least 2, automatic makaka-form ka lagi ng cycle. And G satisfied that condition, right? Ang mga edges niya even. So that means that's at least 2. So by lemma, G contains a cycle. So sabihin natin nakakita tayo ng cycle, tawagin natin cycle C. If C contains all the edges of G, then we are done. Kung ang C mismo na-contain na niya lahat ng edges ng G, di tapos na tayo. Tama? Okay. So what if that's not the case? What if si C is a cycle na hindi naman niya nadaanan lahat ng edges ng G? So ang gagawin natin, tatanggalin natin yung lahat ng edges ni C from G para makabuo ng bagong graph. Okay, so ganito nangyari. Just to imagine. So let's say this is our original graph. So by lemma, dapat makakita tayo ng cycle dito sa G natin. To check all the vertices, ang assumption, all the vertices ng G has even degrees. So ito degree 2, degree 4, degree 2, degree 4, degree 4, degree 4, 2, 2, 2, 4, 4. So 1, 2, 3, 4. Again, pagka loop yon ang incidence ng dalawa, dalawa. So any of these vertices has even degrees. So choose any cycle. Siguradong may makikita ka dapat na cycle because of the lemma. So let's say we choose this cycle here. Yan. So that's our cycle C. So ang gagawin natin, we will remove the edges of C from our graph to create the graph H. Now possibly H will become disconnected. So if we remove C in our G, ito yung makukuha nating result. So nawala na yung cycle C. So that's our H. So ano yung H natin? H is a possibly disconnected graph with fewer edges than G. Kasi tinanggal nga natin yung mga edge ni G, di ba? Okay. Now, kung tatanggalin natin si C sa edge, kada isang vertex na na kay C, ang matatanggal mo, dalawa. Right? Or, ibig sabihin, even number of edges yung natanggal mo. Okay. So, since C has either 0 or 2 edges at each vertex of G, then each component of H is even. Right? Pag nag-alis ka, pag inalis mo yung C, pag yung vertex na yon nasa C, then dalawa yung nawalang edge sa kanya. Right? Nawala yung dalawang edge. So, yung matitira, even pa din. Pag yung edge wala doon sa C, then pag inalis mo yung C, walang mawawalang edge. For example, this vertex, wala siya sa C. So, nung tinanggal mo yung C, kung ano yung number of edges incident to that vertex, yun pa din. Pero pag ang tinanggal mo pag yung vertex ay na kay C, yung H, sa vertex na yon mawawalan ng dalawang edge. Right? So, any vertex na kay C, as a vertex of H, nawalan yun ng dalawang edge or zero na edge. So, either ang inaalis mo lang, zero edge or two edges. So, ibig sabihin, si H, even pa din. Lahat ng vertices niya, even pa din ang degrees. Right? Okay. So, meron tayong even na graph. Meron tayong even na graph, yung H. Bawat component ni H even. Pero lahat yon less than M na ang degrees. Right? Kasi inalis mo yung C eh. So, nabawasan na yung number of edges ni G. So, lahat to ay mga even na graph pero less than M ang degrees. Okay. So, ano sabi ng induction hypothesis natin? Pag meron tayong even na graph, right, na ang degrees ay less than M, laging Eulerian yon. Ibig sabihin, for each of the component, makakakita dapat tayo ng Eulerian Trail. Yan. So, for example, sa ating first component, so, gawa tayo ng Eulerian Trail. You can choose any starting point. So, let's say I start here. So, gawa ako ng trail. Right? So, follow ko lang naman yung edges. I just need to decide kung saan ako pupunta pag meron ka ng mga junction. So, in this case, let's say gusto kong pumunta dito sa taas. Now, at this point, tatlo yung possible scenario. But I don't wanna go back yet sa S, sa starting point. Kasi, kailangan ko pang i-trace yung iba pang part ng graph. So, hindi muna ako babalik. So, let's say, punta ako dito sa loob. So, in this case, wala na akong choice kung di pumunta dito. Yan. I-follow na yung ng mga natitira pang edges until I go back to my starting point. So, I was able to find a Eulerian Trail. Now, of course, kung ang component mo ay isolated, you no longer need to find a trail on those isolated points. So, dito na tayo sa diamond here. So, I can start at any point here. So, let's say I start here. I follow. Of course, this is very obvious. Isa lang naman yung circuit na pwede mong daanan. Paikot lang dun sa diamond or sa kite. Okay. This is another component. This is square here. So, it is easy to follow the trail. Right? Okay. And for the loop, of course, either you go clockwise or you go counterclockwise. Wala ka naman ng choice. Isa lang naman yung loop mo. So, each of them are Eulerian graph. Right? So, since each of them are Eulerian graph, then we can find a circuit, a Eulerian circuit for each of the component. Note that by connectedness of G, each component of H has at least one vertex in common with C. Right? For example, this first component here, meron siyang common with C, this point. This component here has two common component with, or two common vertices with C, this point and this point. The square has common components, this point and this point, and the loop has the same, has common vertex. So, kada component, laging may ka-common doon sa tinanggal nating circle. Sa tinanggal nating cycle rather. So, to obtain the required Eulerian trail for G, all we need to do is we traverse C. But here's the technique. When a component of H is reached for the first time. So, pagdating natin doon sa common component with C, ang gagawin natin, magdi-detour tayo doon sa component na yon through that common vertex. We detour along the Eulerian circuit of that component, adding to our trail. So, sisimulan natin doon sa cycle C natin, pero once na narating natin yung component ng H, for the first time, susundan natin yung Eulerian circuit ng component na yon hanggang makabalik tayo dun sa common vertex. Tapos, tuloy lang natin. We continue along the edge of C until we reach again a vertex belonging to another component of H. So again, pagka may bagong component, didetour na naman tayo in this component hanggang makabalik tayo dun sa common vertex and so on until makumpleto natin yung pag-traverse sa C. Okay, paano yan? Imagine, this is our H and then na-remove natin yung C. So ibabalik natin yung C, ititrace natin yung cycle natin starting from any point on the cycle, then every time na may makikita tayong component from the common vertex ng component na yon, ifa-follow lang natin yung Eulerian circuit ng component na yon. Remember, every component has a Eulerian circuit. So let's say we start at this point of the cycle. So we trace the cycle and then once we've reached a component, iikot lang tayo dun sa circuit, sa Eulerian circuit once. So this is the Eulerian circuit a while ago that we made on this component. And then once we're back here, tuloy na natin yung cycle. Now, meron na naman tayong nakitang component. So, follow lang natin yung circuit ng component na yun. And once we're back, tuloy na natin dun sa circle. So, may another component, follow mo ulit yung circuit, and then cycle ulit. Now, this component is already traced, so we no longer need to retrace it kasi once lang tayo dadaan. So, lalagpasan na natin ulit, tuloy na tayo. This component is also reached a while ago, so tuloy na tayo. Now, nakadaan na naman tayo ng bagong component. So, you just have to retrace the trail. So, kung naaalala pa yung trail from here, punta tayo dito. Kanina, nung gumagawa tayo ng Eulerian Trail, dito tayo nag-start. Pero, since dito tayo ngayon mag-start, ipapalo lang natin yung circuit na yun, the same manner. So, we don't need to start here. Since in a circuit naman, kahit saan ka mag-start, basta tuloy mo lang yung same, i-trace mo lang yung same trail na dinaanan mo kanina. So, this is how we trace it kanina. Yan. And then, balik ka na dito. So, balik ulit sa cycle mo. And then, you now reach the starting point again. So, you're done. And as you can see, you were able to trace the whole graph once and only once for each edge. So, indeed, you were able to find a Eulerian Trail. Since a Eulerian Trail exists, then that means that this graph is Eulerian as well. So that completes the proof of induction. Now we can summarize the method on how we create a Eulerian trail by Fleury's algorithm. So let G be a Eulerian graph. The following construction is always possible and produce a Eulerian trail of G. Start at any vertex U and traverse the edges in an arbitrary manner. Kamukha ng ginagawa natin kanina. Basta traverse ka lang in arbitrary manner, subject only to the following rules. Number 1, erase the edge as they are traversed. So, para hindi ka malito na nadaanan mo na ba siya or hindi pa, ang gagawin mo, i-erase mo lang yung edge na yon. And if an isolated vertices result, erase that too. So, basta tuloy-tuloy ka lang. Pero kung may natitira pang edge, ibig sabihin, pwede mo pang daanan ulit later yon, yung vertex na yon. Now, at each stage, use a bridge only if there is no alternate. Meaning, wala ka nang ibang dadaanan kundi yung bridge. Pero anytime na meron pang alternative, last resort mo yung bridge. Yan. So again, you can start at any vertex and then you can trace any edge arbitrarily at each stage. Pero, kailangan mo lang sundin yung dalawang criteria. I-erase mo lahat ng matatraverse mo na. And every time you pass through an isolated vertex, ibig sabihin, wala nang edge coming from that vertex. You can erase that as well. And then at each stage, you use a bridge only if necessary. Kung wala talagang ibang pwedeng daanan, kundi yung bridge na yun. So always, last resort ang bridge. Okay, let's have an example. So let's say we have this graph. So to check that this is Eulerian, ang sabi ng theorem natin, dapat lahat ng vertices ay of even degrees. So check natin. Yung A ay 1, 2, 3, 4, 5, 6 vertices. So check ang A. Ang B ay 4. Ang C ay 1, 2, 3, 4, 5, 6. So check. Ang D ay 4, ang E 6, ang F 4, ang G 6, ang I 4, ang J 4, ang K 4, ang L 4, ang M ay 8. So our graph is even. So therefore, it's Eulerian, right? So all we need to do is to find a Eulerian trail. So how do we do that? We start with any graph. O, sige. Start tayo, let's say, arbitrarily. Let's say we start at I. Okay, start at I. So, ang gagawin natin, once we trace an edge, buburahin na natin siya, pero ililista natin kung saan tayo papunta para lang makip track natin. So, let's say, from I go to G. So, IG. So, let's erase IG. And then, from IG, so sabi arbitrary, so kahit alin lang, pili ka lang arbitrarily. Basta, wag lang yung bridge. Okay, so I can go GM. GM. Right? From M, I can go back to I. And then from I, let's choose L. From L, let's choose M. From M, let's choose J. From J, let's choose. So I cannot choose I since I is a bridge in this stage, right? Because that will connect I from the rest. So sabi nung criteria natin, last resort mo dapat yung bridge. So I can choose A or K. So let's take the JK route. And then I can choose M again. And then from M, I can go out to E. From E, I can choose L. And then LK. And then KC. CM. MA. I cannot choose J because J is a bridge. So I'm choosing AC, CE, EG, GA, AH, HB. I cannot choose A because AB is a bridge. So let me choose BA, BC rather. I have no choice but to go to D, CD. From D, I cannot choose B because BD is a bridge. So let me go to DE, EF. I cannot use D because that's a bridge. So let me choose FH and then HG. And then this time I'll just trace the rest and follow the remaining trail. So that's GF and then FD and then DB and then BA and then AJ and finally JI. And that's your end. So this is a Eulerian Trail. So that's how you construct a Eulerian Trail in a Eulerian graph. So you can use this technique, of course, if you are already sure that the given graph is Eulerian. Again, that's easy to determine. Just find the degrees of each of the vertices. If all of the degrees are even, then that's a Eulerian graph. Now, a Eulerian Trail or your Eulerian circuit need not be unique. Kasi at any point doon sa stage natin, unless it's a bridge, meron tayong ibang choices eh. So, depende din sa choice na yun, pwedeng mabago-bago yung possible combinations ng mga succeeding edges na pipiliin natin. Right? So, we have many different possibilities. Pwede tayong mag-start at any point, pwede tayong kumuha ng any edges. But of course, there are only finitely many for a finite graph. Siyempre, finite lang naman yung starting point. And for each starting point, finite lang naman yung mga possible edges na pwede mong daanan. So eventually, you'll have a finitely many distinct Eulerian trail. Let's have another example. Now, the advantage of deleting the edges is it gives you an easier way to determine whether at that particular stage, the remaining edge is a bridge or not. Madali mong nade-determine kung bridge yun or not eh. Kasi nabura mo na yung the rest eh. So, hindi kailangang bridge siya sa simula. Basta at that particular stage, kung saan na-delete mo na yung mga naonang edges, kung yung edge na dadaanan mo ay bridge or not. Madaling nakikita yun kung na-delete mo yung iba. Pero pwede na naman kung hindi mo i-delete. Basta kaya mo lang i-keep track kung alin yung magiging edges or not. Okay, for example, let's start at A here for simplicity. So let's follow a trail. This time, hindi ko i-delete. Pero in our mind, dapat naisip natin na nadi-delete siya. Pero lalagyan ko na lang ng white para makita natin yung difference. So let's follow AB. So we start at A and then we follow AB. Now from AB, we can go to BC and then CD and then DH, HL, LP, PO, ON, NM, MI, IE. Now at this point, so I just traced the exterior edges. At this point, I can go to A, B, or F. But since we already deleted edge AB, AE is now a bridge. Right? At the back of our mind, alam natin na delete na natin yung AB eh. So madi-disconnect si A pag dinilit mo yung AE na edge. So that means the edge AE is now a bridge at this stage. In our trail, AE is a bridge. Diba? Kasi na-delete na si AB. So, iiwasan muna natin yon kasi bridge yun eh. Sabi nung rule natin, basta bridge, last resort mo. Okay. So, either punta ka kay B or kay F. O, de, punta tayo kay B. Yeah. So, EB. So, from here, wala na akong ibang choice kundi pumunta kay F. Again, kailangan medyo conscious tayo here. Si EF is now a bridge. Kanina hindi pa siya bridge, yung naka-E pa lang tayo. Pero at this point, si EF bridge na siya. So hindi ko siya pwedeng puntahan agad. So punta muna ako kay either kay I o kaya kay G. Sabi natin kay I tayo pupunta. J rather. Sabi natin kay J tayo pupunta. So FJ. So from J, punta tayo kay I. JI. So, wala naman tayong choice kundi pumunta kay N. Right? Yun na lang yung natitirang edge out from I. So, IN. And then from N, balik tayo kay J. Wala nang ibang choice. From J, baba tayo dito. Wala na rin tayong choice. Now, here, either we go G, L, or O. We cannot choose G because GK is now a bridge. Right? So that's the problem when we don't delete the edges. It's hard to see whether the edge that we're going to traverse is a bridge or not. But if you look at the remaining edges we haven't traversed, then deleting GK will actually disconnect the remaining edges, right? So that means GK is a bridge. So let's let's go to either L or O first. So if I go to L, so that's KL, and then I go to LO, and then from LO, I have no choice but to go to K, and then from K, I have no choice again to go to G. Now, from G, I can go only to C or H because GF is now a bridge. So let me go down to H, and then to HC, and then to CG, GF, FE, and finally back to A. Okay? So that's our Eulerian Trail. So again, it's easier if you can delete the edges as you traverse the edge, but again, if it's not possible to do so, for example, you're doing it in a paper using a pen, so it's not possible to delete an edge. But if you're using a pencil, of course, it's possible to delete an edge. So if it's not possible to delete an edge, you need to be very careful whether an edge you're going to traverse is a bridge or not. Basta ang rule natin, pag bridge yun, last resort. So, unless wala ka na talagang ibang dadaanan, kundi yun na lang, tsaka mo lang dadaanan yung bridge. Pero pag may iba pang pwedeng daanan, doon ka muna sa hindi bridge. In general, that's how we construct a Eulerian trail.